Recording in
there.
progress.
Hey there, everybody. Welcome back. We're going to be doing some more statistics today. This is Intro to Stats at Colleges of Sequoias in fall 2022. We are in the Sullivan Math Lab Pearson program. Chapter 11 is what we're looking at today. And that's on two sample hypothesis tests. That should say sample. This pen is way too thick. And 11.1 is on proportion tests. And since we've gone through a chapter on hypothesis testing and a chapter on confidence intervals, I thought I'd do a quick recap on some of that stuff and how they connect. And we'll take a look at it as we're chugging along. So we looked at confidence intervals. And we had, well, I'm going to call that CI from now on, just as a reminder. And it was generates or is a range of values based on the sample data. That is likely to include an unknown parameter. An unknown population parameter in specific. Something like mu or sigma, p maybe. We could do variance, sigma squared, something like that. And hypothesis testing. Oh, the orange looks like blue or red, so I'll switch to blue. This is a process for testing a claim. Based on sample data. About an unknown population parameter. Yes, I can write that stuff down. As you can see, they are both based on sample data, and they're both in regards to an unknown population parameter. And there is a direct link. So the hypothesis test, this includes the null hypothesis, H naught, Remember that comes with an equal sign. Always has the equal sign in it. What the hypothesis test is doing is this. Is H naught within the limits of the confidence interval? How does it do it? Remember, we need alpha, the level of significance. Frequently is 0.05. And alpha is the level of significance. I'm going to write that up here. Oh, I spelled it right today. Good job, David. On the two-tailed test, our CI is 1 minus alpha times 100%. And on the one tail, it's 1 minus 2 alpha. The two tails one is the does not equal. The one tailed test is either the less than or the greater than. So as we go through these tests, well, let's double check that and look at it while we're going. If you need that longer, let me know. Otherwise, we'll continue. Leaving in 5, 4, 3, 2, 1, lift off. So, two sample proportion test. This is our new material. This is when we are comparing the proportions for two different groups. And since we have two groups, we have two proportions. We'll call them P1 and P2. That I looked over that number 2 to me looks like the greater than or equal sign. I'm gonna rewrite it so it's it totally looked like this to me when I first looked at it. And I'm like, I wrote that. I know that's not what it means. Okay, so important to start off. It's important to note all the old rules still apply. For proportions. For example, like our n times p times 1 minus p needs to be greater than or equal to 10. Needs to hold true for both groups. That's just when for one sample. When we kick it up to 2 samples, n times p1 times 1 minus p1 needs to be greater than or equal to 10. And n times p2 times, times 1 minus p2 needs to be greater than or equal to 10. We also had the rule that n had to be less than or equal to 5% of the overall population. This has to be true for our groups. And I made a little mistake here. I just wrote n. There's no requirement that n's are the same. They should in fact be different groups, and they don't even have to be the same size. So I'm going to change that to n1 and n2 up there. But this translates to n1 should be less than or equal to 5% of the population. And n2 should be less than or equal to 5% of the population. And if they come from the same population, like we're talking about humans and then like guys and girls, n's kind of the same, but we can break this into n1 and n2 like that too. Okay. We also have the samples need to be independent. Simple random samples. So what I mean one or independent, one population or one group shouldn't have a relation to the other, down to a single member. Like, don't take a married couple and put let's assume a homogenous or heterosexual marriage, not a homogenous, heterosexual marriage. Don't take a married couple and put the guy or the husband in the guy group. And wife in the female group. if their responses might be related. Like if you're asking them about their interests, they might have similar interests. That's so often why people get married. They have stuff in common. If you're asking them about children and they have children, they definitely have something in common. If you're asking something about like where they were born and raised or where they went to school, you might have some leeway. They might not have any relationship between them. They met as adults, kind of thing. But you would probably want to verify that before you added them. I do these lectures from my office, and I have my in my house, and I keep the door shut. And I showed you guys our new puppy. He's now is very, very affectionate towards us. He likes us now. So when I open the door, he comes running, circles my legs, pounces on me. It's a lot of fun. He didn't do that for a couple weeks. Now he does it every time I open the door. He comes running to see if it's me. He hears a sound. Is David coming out?
He was getting used to you guys.
Yeah, he was getting used to us, and there's something about puppies, kittens too, young pets that are just so soothing to the soul. Which, for some reason, to me, human babies do not do that. Like puppies are sweet and affectionate and don't wake you up. Well, he did for a while. He's not now. But they don't wake you up every 2 or 3 hours for months on end while they're learning how to communicate, go to the bathroom and stuff like that. Want to eat. You know what I mean? Everyone's seen or heard about it. If you don't have kids, I don't have kids, but I've heard the stories. If you need that back up, let me know.
It's
Uh,
not that bad, I promise.
what? Oh yeah, you have one.
I said it's not that bad, I promise.
I don't believe you. I've heard enough from other people that it is bad. It's terrible. Maybe you have a good baby, like a well, I hate to say good baby, but quiet baby. Maybe that's a better way of saying it. All right, so in StatCrunch, what do? No one wants to do this shit by hand. We're gonna go stats, proportion stats, just like we did with one sample. Two sample. And we have the options of doing data, uh, summary, and power sample size. The ones we're going to use the most are data and summary. We have a 5-step hypothesis test. The first step has something different. I told you H naught and HA change for each group. So in reality, in the real world, the way we describe H naught is, does P1 equal P2? And does P1 not equal P2 or be greater than or less than? This makes sense to people in real life. Like, do the proportions match for both groups? Do men and women both like chocolate kisses just the same? The cherry cordial Hershey Kisses that are out again. Oh, they're so good. So that's not how StatCrunch does it. StatCrunch does it slightly different. What they do is they subtract P2 from both sides. And what we end up with is H naught is P1 minus P2 equals 0. And then HA is P1 minus P2 does not equal 0. Or it's greater than, or it's less than, depending on what the thing is. And there is a perk to this. There's a benefit in doing what StatCrunch has, because here in the top one, they're forced to be the same. But in StatCrunch, this is an editable field. And what do I mean by that is P1 minus P2 equals 0 is saying, let me do greater than 0, is saying P1 is bigger than P2. But if I can change that to say P1 minus P2 is bigger than like 0.1, now I'm saying P1 is bigger than P2 plus 0.1, or P1 is 10% larger. So if you're trying to check to see if something's not just bigger than or less than, but how much bigger or less than, and you have a hypothesis about it, that's something you can test. So we're going to jump into problems in just a second. I just want to give some pro tips now that we're getting into the 2 sample things. If you need that up longer, let me know. And it will come back. So David's pro tips. My notes, the notes I have for pro tips, I wrote the wrong word. I know what I meant to write. Read the problem a few times. Or at least more than once. Sometimes you skip words when you're reading it. Is Isabella here? Isabella's not here. I was working with Isabella, and she read through the problem, and she managed to skip over 3 words, and it was the exact 3 words the problem was looking for. And I watched her do it. She was using she was sharing screen. She was moving the mouse as she was reading it, and she kind of like sped up over a certain spot. I'm like, did you? She kept going. I'm like, did you read that? Did you read that spot right there? And she looked at it. She goes, no. I'm like, well, yeah, slow down. You need to. So Isabella, yes, you know what I'm talking about when you watch this video later. Number 2, We have 2 samples, so label them. If it's guys and girls, put P1 equals guys, P2 equals girls. Literally write it down so you have that information written down. This doesn't matter as much. Less important, but you should still do it for the end. When we are doing P1 not equal to P2, but if we are checking P1 greater than P2 or P1 less than P2, like guys are bigger, like guys do something more than girls or like something more than girls, or vice versa, girls like something more than guys, we need to have these in the right order. Because depending on which population we name them, and we'll do it in a problem in a little bit, I'll show you how that changes HA. This affects HA by which order we put these in. So you need to label them. And on the final exam, you're going to need to label them. If you don't label them, I'm going to assume you are bullshitting me, and you're not going to get very many points. When they give you summarized data, write it down. N1 equals dot dot dot. P1 equals dot dot dot. N2 equals dash dash dash. P2 equals dash dash dash. That makes it sound like they're the same. There we go. Different symbols. And don't forget to look for alpha. It doesn't always say alpha. Sometimes it says level of significance. If it's listed there and you use the wrong alpha, you'll get it wrong. It's not always 0.505. And with that, we're ready to do some examples. Oh, I hate this section. I hate the example in here. And I know why. I even wrote what I should say so that I don't fuck it up. But I'm going to let you see me try to pronounce this word. And other people pronounce it just fine. For me, I can't fucking do it to save my life. If you need that up longer, let me know. Otherwise, we're going to open up the Math 21 lecture notes.
Can you put it back up, please?
Yes, I can.
Thank you. I'm good.
That was quick.
Yeah.
All right. So let's move to the side. Recall we have in our file section, you can grab the Math 21 lecture notes if you didn't download them last time. I'm going to reference them again. if you downloaded them and saved it where you were at, it when you open it back up, it like says, "Do you want to jump to that spot?" Which was convenient because I did. I jumped to like right up here, and I'm like, I just have to scroll down a little bit. So I am in 11.2 section, and it is gonna be. It says 122 right there. So we're looking at example 2 in the lecture notes. Page 122 in lecture notes file. Oh, my Zoom picture window is in the way. Let's move it over here. Okay, so it says an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. He obtains a random sample of 800 urban households and finds that 338 of them have internet access. He obtains a random sample of 750 rural households. Wow, I'm getting better at saying it. And finds that 292 of them have internet access. Test the economist's claim at the alpha equals 0.05 level of significance. So, we're talking about does urban have a greater percentage than rural? And I'm going to use the word country rather than rural because I feel like I'm like stroking out. Like when I say rural, it sounds wrong to me in my head, in my ears. So country and rural kind of mean the same thing. Country's easy to say. So for now, I'm going to label them. I'll label urban P1 and country P2. Okay. So then it says the random sample of 800 urban households. Urban is my P1. So N1 is 800. That's my sample size for the 800 group. And my P1, it doesn't give me a proportion, but it gives me the X. X is 338. And then when we get to the country households, which is my P2, I'll give it a 2. It tells me there's 750 homes that they checked. And X2 is 292. And I'm going to make a quick note that alpha equals 0.05. And in the words of the person, urban or the economist, urban has a greater percentage than country or rural. So we need our results to match that. So I've labeled urban P1 and country P2. So if I move the P2 to the left, I have P1 minus P2 is greater than 0. That's that little algebra step right there. And that will be my HA. So H naught will be the one with an equal sign. Before I continue, I want to show you what happens if you label them the other way. If I label country P1 And urban P2. I still need urban to be greater than country. That hasn't changed. But now this is P2 and this is P1. And if I move the P, I want I want it to say P1 minus P2. So I need to move the P2 over here. And I'll have 0 is less than P1 minus P2. And if I swap the order of these around, if I put the P1 minus the P2 on the left and the 0 on the right, the alligator is going for the 0. The alligator needs to go for the 0 now. So the sign changes. So I have P1 minus P2 is less than 0. And then HA is still P1 minus P2 equals 0. Notice the difference. It's subtle. It doesn't jump out at you. They look the same other than this has a greater than symbol and this has a less than symbol. And if you put the wrong ones in the wrong areas, it's going to give you the wrong answer. Okay? We're going to do that top one though. And we're going to do it in StatCrunch. So we're going stats, proportion stats, 2 samples. And we don't have the data, we have a summary. So I labeled population 1 urban. So I'm going to put the urban data in sample 1. I've got 338 and 800. And for sample 2, I've got 292 and 750. And my hypothesis test, my alternate one is the greater than sign. And we're just using 0. We don't want to change this. Notice if you change this, it changes it down here also. So that's convenient. Very rarely do we change it. I hit enter before I wanted to. All right, so we got 338, 800. We're doing 0. We got the right symbol. We're going to click compute. And I'm going to go ahead and bring up another whiteboard. If you need this one up, let me know. I'm going to rewrite down our null and alternate hypothesis, though. Our null, I'll rewrite what we had. P1 is urban. P2 is country. And our test is urban is greater than country. We had H naught was P1 minus P2 equals 0. As StatCrunch tells you, it rewrites what you've done. Notice it over here. So it gives me my z-stat. That's my test statistic. So my z-stat is my test statistic. Oh, we had alpha equals 0.052. Those were our first two stat. Oh, 0.5, not 0.5. So Z-stat is 1.329. Notice we don't do anything with it, but if you're writing a research paper or something like that, and you've got the data or summarized data, people should be able to run the same hypothesis test and get the same stat number. That's their way. You listing the Z-stat or test statistic is your way of giving them something they can verify. And then we have the p-value is 0.092. So that was step 3. Step 4 is to compare them. So my p-value of 0.092 and alpha is 0.05. My p-value is greater than alpha. If the p-value is too low, reject the hoe. If the p-value is not, do not reject. H naught, do not support HA. And when you're doing stuff like on the final exam and stuff like that, if you write DNR H naught and DNS HA, I'm cool with that. I like to use that abbreviation myself. I know DNR means something else, but we're not a nursing field, so or at least I'm not. You might be a nursing major, but I'm not. DNS means something else too, I'm sure. Huh. So, step 5, conclusion. We are not supporting HA. We can't support HA because we don't have enough evidence. There is not enough evidence to support the claim that, and we were talking about urban and country, and I'm going to just bring up the document again. That urban households, that the percentage of urban households with internet access is greater than the percentage of rural. And you'll notice that the last part of my sentence is basically, if I were typing it out, I could have just copied and pasted it. Starting with that, all the way down to that is directly from the sentence that's been typed up already.
I have a question real quick.
Yeah.
Okay, so it says there is not enough evidence to support the claim, but isn't it greater than the level of significance? That always confuses me.
Yes. But being greater than means it's not rare enough. We want it to be less than the level of significance. So if you have in your head it needs to be greater to support it, just keep telling yourself that you're wrong. To me,
Okay, because I was having a hard time with the homework, with chapter 10 homework, because it was like, oh, reject or doesn't reject. And I'm like, what? That doesn't make sense to me. But I figured it out eventually.
for me,
But
that's how
it's
skewed left
confusing.
and skewed right is. Skewed left to me, I want to say skewed left is where the hump is the biggest, and it's not. It's where the tail is the longest. So for like even teaching it for 2 or 3 years, I still have to stop and go, okay, whatever my natural intuition is wrong. I've taught it long enough that I'm comfortable with skewed left means the tail is on the left. I no longer think of skewed left as the hump on the left, but for the longest time, but I kept telling myself what I think is natural is wrong. So flip it around. Maybe seeing how it connects to the confidence interval might help to lock it in a little bit better. So let me bring that back up. This is a one-sided test. So on one-sided test, we can do 1 minus 2 alpha. And alpha is 0.05. So this is 1 minus 2 times 0.05. This ends up being 0.90 or 90%. So let's do this stuff with a confidence interval of 90%. I'm just going to go in and edit it, and I'm going to click on confidence interval. And click compute. Oh, it just barely includes it. That's not good. That doesn't work for what I was about to say. What do I have off? What is... Let me see. Make that 9. Go the other way. 975. Nope, still doesn't do it. The idea is checking to see if H naught is in the... Oh no, this does work. This is exactly what I wanted. I just had it wrong in my head. So the hypothesis test does this. Is H naught in the interval? Inside the lower limit and the upper limit. The lower limit is a negative number. The upper limit is a positive number. H naught is 0, which is between the two. So H naught is in the interval. How am I doing on that? Let me write it on the damn board. Being a dummy. So, is H naught in the interval? So, I did the 1 minus 2 alpha, and I got 90% CI. And when I do the CI, I get my lower limit is negative 0.008. And my upper limit is 0.074. H naught on a number line we had 0. P1 minus P2 equals 0. 0, like if that's negative 0.08, and that's 0.074. 0 is right there. It's really close to not being inside the interval. It's really close to it, but it's still inside. Since it's still inside, we can't reject it. It might still be true. If we did a different sample, we might get different results. And there's a good chance we'd get different results because it looks like the proportion is quite a bit different. It looks like the middle of it's over here. So maybe if we did another sample, we'd show it outside of it. And this just might have been two bad samples where it was weighted funny. But with the evidence we have, we can't reject it. Which means although HA might be true, and when I say we can't reject it, we can't reject H naught. HA might be true, but these samples don't support that. But remember, the confidence interval we had was 90% confident. So we're not 100% confident. Since it's so close, if it was really important to me that I prove it or verify this, I'd probably do new samples. Just to see if I had bad samples on the first one. Although 750 households, 800 households, that's a lot of households to ask. I might also check to see if the samples were all in the same county. Because if they are, maybe it's definitely not independent. We need to check samples from, get some urban households and some rural households in different counties throughout the country and check it that way. So for the P1 and P2, so we had urban and country. This, I don't know if you guys, you like this better or not. I know we're going to have, it said urban was greater than country, so I know I need to have P1 minus P2 to be greater than 0. If I write it the other way around, if I label it wrong, T1 minus 2 P2 is less than 0. To me, I want the wording there to match the wording here. That's not there. That's there. I can label if I do. So here I had urban was P1 and country was P2. If I do this one down here, I'm going to show you it's the case too. If I say country is P1 and urban is P2, I will still get the same test results as long as I put everything in the right spot and use the right symbols. But for me, when it says urban is greater than country and me trying to plug in something that says less than 0, this says greater, this says less, it just fucks with my head. It bothers the shit out of me. Like, I don't want to do that. So I will, even if I pick the words first and it doesn't match up, like if I did this first and I see I get this, I would switch my groups so that I could have that. Because I want the symbols to match up in my head. And it might be easier for you to do that as well. So, check this out. I'll do a new proportion stat, 2 sample with summary. I'm going to switch around the data. It was 292, was it? $292 and $750. That was the country, and the rural was no, that urban was 338 and 800. Here I'm going to do less than. And I click compute and notice, oh, I got to go back and do hypothesis test there too. On one of them, the hypothesis, the one with the greater than sign, the z-stat is positive. The other one is negative. But the thing I'm basing my decisions on is the p-value. And the p-value is the same. If I put the wrong symbol here, notice my p-value is wrong. What I have listed on the screen right here is country is greater than urban. The way I have it written on this box right here, which is not what the problem asked, which is why this is wrong. Okay, so make sure your wording matches what your symbols are. I think it's easiest to pick the groups such that the wording of the sentence matches the wording of the what I got to do in the hypothesis test. Let's do another example real quick. Example 3, let me make it larger. So a group of COS students feels that, another whiteboard here. I went through a lot of whiteboards today. That there's a difference between the proportion of female students that change their major. We're talking about COS students. And the topic is changing majors. And they think that females, there is a difference. Difference means different or not the same. So the female proportion is different than the male proportion. To test this claim, they did a survey. There was, I'm going to use F for female. There was N equals 80 females. And for M, there was 86 males. And it says, of the students surveyed, 39 females changed their major. Again, they didn't give us the percentage. They gave us values, which is what we want for the hypothesis test. And 51 male students changed their majors. Test the student's claim at the 0.05 level of significance. So the not equal should be fine. It doesn't matter which one we label which. So I'll just do them in order. They talked about females first and males second. I'll use that order. So I'm going to do P1 minus P2 equals 0. And P1 minus P2 does not equal 0. Okay. Let's go to StatCrunch. Proportion stats, 2 sample with summary. I've got 39 and 81. And then I've got 51 and 86. That 51 looks a lot higher than the 39, and there's only a gap of 5 in them. So I suspect they're different. But we'll check. We are doing the not equals version, so it's good to go as is. So I'll click compute. And I get my z-stat. Negative 1.445. And my p-value is 0.1484. So we'll compare our p-value. To alpha. And it's bigger also. Before I jump to the sentence. So the p-val's too low, reject the hoe. The p-val's not too low, do not reject the hoe. Do not support HA. DNR, do not reject, do not support. That goes with not too low. So not, and not. So the claim was, let's come back and look at the claim. Make sure that I say it right. I know it was on changing majors. And students feel that there is a difference. And it looks like there is. But there is not enough evidence to support it. There's insufficient evidence to support the claim. Right from the screen that there is a difference between the proportion of female students that change their major at least once. That sentence reads bad. It shouldn't say is different again. It already says different. There's a difference between the proportion of female students that change their major at least once and male students that do. That way it reads a little bit better next semester when I teach this again. I have a note in here that I want to go look at homework number 5 for you. So we should do that. I think before I do that, I'm going to come back to this problem though again. And I'm just going to edit this to show that, do the confidence interval. And we do 2 times the alpha, which would be 10. And then subtract that from 1. So 1 minus 0.10 is 90. And we can see again here that 0 is inside the limits. Now again, it's pretty close. What am I doing over there? Negative 0.23 and 0.01. This shit's really close to the right edge. H naught is barely inside the confidence interval, but it is inside. So maybe a different samples for each group would yield different results. Okay, let's come over to the homework and open up chapter 11's homework. And let's see what I got in here. Getting near the end, aren't we? Only a couple homework assignments left. Let's take a look at number 5. Researchers wonder if there is a difference between males and females in regard to some common annoyances. They asked a random sample of males and females the following question. Are you annoyed by people who repeatedly check their mobile phones while having an in-person conversation? I don't have any more whiteboards, so I'm going to use a piece of paper. So, are you annoyed? Annoyed by cell phone users in combo. In face-to-face conversations. And they think there is a difference between males and females. So the males, 583 were asked. That sounds like an N. And 234 said yes. For females, 502 were asked. And 213 said yes. Now, the males got a higher number than the females, but it has also got a higher sample size. So, might be off. First question. The proportion of the females and males who took the survey who are annoyed by the behavior in question are, and they want 4 decimal places. This is not at the hypothesis test yet. So they wanted females, and even though they talked about males first in the sentence, look at this tricky shit. They said males first and then females second. So that's how I wrote down my data. Now the sentence asks for females first, then males. So I got to put females in the first box. Females is going to be, we're doing a proportion, so we got to do the division. So watch for this shit. They're tricky. Even though they said it in one order, they changed the damn order. That's some dirty, rotten pool. That's some cheater shit. To 4 decimal places. And if I do male, I think that's why I added this stuff to talk to students. I had students get the right values, put them in the wrong spots, and never recognize that they changed the fucking order of this shit, which is rude. It's a dirty trick. Okay, so explain why this sample size can be analyzed using these methods. Oh, I didn't do this for the other ones because I saw n was really large for both of them. Here, we want to make sure that the samples are independent. The sample size is less than 5% of the population size for each sample. I will assume that 502 and 583 are less than 5% of all students in the country. Seems reasonable. And we need this to hold true. So we should probably check it. So for females, N was 502. 502 times 0.4243 times 1 minus 0.4243. And make sure if you're doing it in a calculator, use parentheses or do the minus sign stuff first. I'm getting 122, which is 122.6. That's greater than or equal to 10. That was for females. For males, 234. Nope, that's not the sample size. 583 was the sample size. This is definitely going to be true. But let me just figure out what it is. Times parentheses 1 minus 0.4014. And I get 140.1. Also bigger than 10. So we meet the criteria for 3 reasons. We don't know that it's normally distributed, but we assume it is. And because we met all these descriptions. N times P were bigger and stuff like that. Now it says, what are the null and alternate hypotheses? They said difference in males and females. And they said, oh, they very much specified females and males here. They said females are going to be population 1 and males are going to be population 2. Again, different than the order that they gave in the sentences. So whoever wrote this problem is an asshat. Thankfully, it doesn't change this stuff right here. Equals or not equals. And it might be easier to say P females minus P males. That way I know which one's which. The fuck? Oh, nope, they even changed. First they said, is there a difference? And then it says, is there evidence to suggest a higher proportion of females? So they even changed the damn sentence. It's not equals to, it's greater than 0. So, they like tricked me more than once. Of course, I didn't read the sentence a couple times out loud and write down what I read. I stopped reading when I got to 213 yes. And that caused me to screw up right now. I didn't actually read this sentence earlier. I didn't follow my own pro tips. So if I change that to greater than, we're good to go. So what do we have for these? I'm going to go grab the information. So if you look back through your notes, and I had to because I don't remember this, I remembered mu. Mu of p equals p. That one was easy. It's the sigma of p that I don't remember. It's p times 1 minus p divided by n. So, oh, is there a way to do this that's easy in StatCrunch? Let's check. What's this? Is give me the shortcut version of doing it in this. All that. Really? Are they really going to make us calculate it by hand? I guess they are. They want you to do P1 was for females, and that was 0.4243. And then we do the males. And then we take the square root afterwards. So this is a tedious thing. Plus square root of the answer. I am getting 0.02998788. And they want to 4 decimal places for 0300. The mean is my P1 minus P2 is 0. That was the P we're using in H0. A lot of work to do by hand, huh? Now, if we want to do this, see this sampling distribution, see which one's which, we can stick this information into StatCrunch. Where's my StatCrunch calculator? Stats calculator is normal. And we have the mean is 0. The standard deviation is 0.03. And we had P1 minus, this is greater than 0. So looking for greater than 0. Oh, we have our P1 minus P2 in our problem. This is, if we actually calculate it, it's 0.4243 minus 0.4014. That's what I need to do. That's what goes here. I'm getting 0.0229. So that one goes right here. So I can see it's on the right side of the picture. Means in the middle, but it's right here on the right side of it. So that's what I'm looking for. Oh, look at that. They have 0.0229 written down in them. I want that one. So I guess I didn't need to calculate it by hand. The pictures actually had it. That's handy. And now the rest of this is standard. You're doing the hypothesis test. So let's figure out what the rest of the stuff is. Stats, proportion stats, 2 sample with summary. My females are group 1, 213, 502. My males are my second group, 234 and 583. And I want greater than 0. And I have no idea what they were asking here, so I'm going to write down what I got. Z-stat is 0.76515,932, and my p-value is 0.2221. They're asking for one of those two things. I don't know which one. Let me go look. The test statistic. So the test statistic was the 0.765 to 2 decimal places, 0.77. And of course they want the p-value rounded. The hell? If the population proportions are equal, not equal, one would expect a sample difference proportion this is confusing. The population proportions greater than 0. The 222 is 1,000 times the p-value. That's going to be wrong. Oh, 0.05 alpha. 0.05 alpha. We're going to multiply that by 1,000, and we want that smaller than. So 0.05 times 1,000 is 50. If the population proportions are not equal, we would expect a sample difference proportion. I don't know, the wording on this is confusing. So their p-value is 0.227. If the population proportions are equal, one expect a sample difference greater than 227. Isn't that what I said? Didn't I say greater than that? Oh, I said not equal. That's the problem. So the p-value wasn't too low. We do not reject the hoe, which means there's not enough evidence to support the claim. There is not enough evidence. There's two of them that say do not reject. This is the one that says not enough evidence. There we go. That's number 5. That's why I wrote it in here to work out. Pain in the butt. All right, that's it for today. Any questions?
Yes, it's about the project though.
Okay.
I kind of remember it, but I don't remember if you went over it in last class.
I did at the end.
I it's kind of spotty to me. Can you just go over it? Because I know it's in the files.
Yeah.
I just have a lot going on, and so it's not like in my brain, but I know that you spoke on it.
So we're gonna go, and I still have not uploaded the right version yet, or the one with the correct due dates. But you're going into files, and you're going into important documents, and you're going to stats project. Are you a suspect? I will get the fall one in tomorrow morning. The fall one will have the current due dates, which is I think the first week of December. So still plenty of time.
Okay. I just wanted to like try to get a start on it.
Yeah, you can definitely get a start on it. The only thing that's going to change is between this and the other one is this is going to say, I don't know, what is that going to say? Let's go look at the shit. Let me just reopen a closed tab. There we go. It's going to say project is due on Tuesday, December 6th. That's the only thing different it's going to say. Everything else will be the same. Down to the links you use to get to the data set.
Okay, so all the data is the same, everything's the same except for the due date.
Yeah.
Okay. I just didn't want to like do something wrong and put all my hard work into it. And it's completely wrong.
Everything's going to be the same. Just it doesn't have the right due date listed, and I need to change that.
Okay, thank you.
I wonder if I can edit it right here. Nope. I can't. All right. Any other questions? Oh, probably not. You're the only one here? All right, I'll stop recording.
Recording stop.